Okay, this video is to give you a little bit of assistance with the partitioning a segment questions that have been confusing some people. So this is number 2 from your practice worksheet with the 5 questions. So I don't have the problem written up here. You obviously have it in front of you. So C is between A and B. I'm going to do a quick sketch. If you didn't already do so, let's do a quick sketch and see what we have going on here. Coordinates of B is what we're looking for. So we have point A is 1, 2. So there's my A. And then my C is 6, negative 1. And I did give you the graph paper, so you're welcome to use that. Or just give yourself a sketch. It doesn't have to be perfect because I'm not able to count everything anyways. And okay, so that's my segment that I have. So I'm going to go ahead and turn this into a triangle. And I'm going to propose that I know. Okay, so the tricky part here is we're trying to find the coordinates of B. So we know the ratio of AC to CB is 5 to 1. That means that this part here is my 5 and my 1 is over here somewhere, down here. So this line actually keeps going. And C is on AB. We're trying to find B, which is a little different than what we did in class. In class we did where we were trying to find a point on the segment. So it's on the line that contains AC essentially. So that might be if you try to solve for, so I'm going to just go ahead and plot B here. And I don't know the coordinates, but just to kind of get me thinking, I guess I'll leave some space here. Try to get me thinking of, okay, it's down there somewhere. And again, this part here that I added is the 1 compared to the 5 here. So it's going to definitely be shorter. I probably drew a little bit off, but that's okay. I'm just going to try to visualize it from here. Going back to what I had initially, I know those 2 green segments. So that's the next thing I'm going to do is I'm going to take those, I'm going to figure out the lengths of those 2 green segments. And in this, I'm going to find the x distance, that would be this length here, is my change in x coordinates. So that's how far I went over from point A, which has an x value of 1, to point C, which has an x value of 6. So essentially that is coming from 6 minus 1 is giving me 5 there. Okay, and then I'm going to do the same thing for the y values, and I'm going to take the y values, 2 and negative 1, and I'm going to subtract those. So if I'm starting at 2, subtracting a negative 1, I actually want a change of 3. And you could obviously just count those as well, and that should be giving you the same thing. Okay, now the question is, how far do I have to go to get to B? So I could answer this in 2 ways, or think of it in 2 ways. I could think from C, how much further down and over do I have to go? And I actually put solutions in Schoology that are both ways. I put them in that shows that, but I think it might be a little easier for you if you start at A and say, okay, how far do I have to go down and over in terms of how we did the other questions? Because that's going to give me my big triangle compared to my small triangle that are going to end up similar to each other. So I'm going to go ahead and propose that we make a triangle all the way from A down and over to get to B and make those my unknown lengths. So I'm just going to call those D and E for the sake of using a different letter. So D is this entire distance here, and then E is this entire distance. And I'm going to encourage you to pause, make sure you see the similar triangles that we have going here, and then let's see if we can solve for D and E. That's not my answer, but that's going to get me to my answer. So I'm going to set up some proportions here. So if I go with small triangle lengths, I've got 3, 5, and 5. I'm going to use that ratio. And then my big lengths, I've got D, E, and this length over here. Remember, you've got to use the whole length. So my length over here comes from my ratio. The whole thing is going to be 6 parts if it's 5 to 1. So my ratios are going to look like this. It's going to be D over 3. And I'm just going to go ahead and set them all up. You can set them up as separate proportions. D over 3 is going to be equal to E over 5 is going to be equal to 6 over 5. Oops. So that last one came from my ratio of my parts, that to this. Okay, you could obviously flip those. You could set them up as different proportions. I just kind of like to get them all out there. And then I'm just going to do some proportion solving. So I'm going to put the d over 3 with the 6 over 5 because I can ignore this. D over 3 is equal to 6 over 5 and cross multiply there. And I'm going to get 5d equals 6 times 3, which is 18, divide, and I get d equals 18 over 5, which is 3.6. You can keep it as a fraction or a decimal. And then I'm going to cross multiply right here and get 5e equals 5 times 6, which is 30, and divide, and I get e equals 6. Maybe you figure that one out just because if my ratios are going to be equal and I have 6 over 5 and my denominator is the same here, the numerator is going to have to be the same. Okay, so I just found D and E. The problem is that's not my answer. The answer is going to be the coordinates for point B. So the coordinates for point B are going to come from the coordinates of A. Remember, I'm starting at A. So I'm actually going to set this up as I'm starting at A, which is 1, 2. And I'm going to be moving down and to the right. So I remember I moved down this distance D. And then I moved to the right the distance of E. So the X direction is going to be left to right. So I'm going to be adding because I'm moving to the right. So I'm going to be moving the distance of E, which is 6. So I'm going to do 1 plus 6, giving me an answer of 7 for my coordinates for B, my X coordinate. And then for my Y coordinate, I move down D, which means I'm going to be subtracting, and I'm going to be subtracting the distance of D, which is the 3.6. So essentially, this answer came over here, that one came over there. Maybe I should have done my work in a different order. But as long as you keep track of which one's which, so you're not adding and subtracting. Yesterday we had some issues where we were putting the wrong one with the wrong coordinate. Oh, I guess I should finish the problem here. 2 minus 3.6 is a negative 1.6. Okay, if you plot that, that should look pretty good in terms of making sense with your ratio of 5 to 1. Obviously, mine's not a very accurate graph, but if you use some graph paper, it should make pretty good sense. Probably would be hard to get that exact of an answer without doing that math, but it should make sense when you look at your answer at the end. Okay, there are other ways to do this. If you want to see the method that I referenced of small triangle here to this triangle, go ahead and look in Schoology at my answers. Hopefully that helps.